So these questions here, and there's a bunch we'll go through, is kind of taking what we've learned and putting it in context of the real world. Okay? So these are all sine functions that we're gonna go through. Okay? But they're applicable to real world situations. Okay? And what I'll do is I'll go through the first two myself. Then I'm going to give you some time to kind of go through a third one. Then we're going to go through a word question that we'll have to figure out what's going on. And then we'll go through that again. So, Nolan is jumping on a trampoline. The graph shows how high his feet are above the ground. Okay? So you can see like Nolan started jumping. And as you jump on a trampoline, your bounces get bigger. If you're good at it, I do not do trampoline, so mine would always stay like this. So how long does it take for Nolan jumping to become periodic? So how long until he hits this rhythm, a periodic function? Okay. One second, I want to get my note out too. Can you guys tell me how long it takes him to get into periodic rhythm? So I get my note ready. Two seconds, good. So let me get my note out here. Oops. This is Mike's periodic. Okay, perfect. So it takes him 2 seconds to get into it. Good. What is the period? So once he gets into jumping, what's the period of his jump? Okay. You guys tell me what the period is, even though it's written literally on the page. What's the period of his jump? And it's also 2 seconds, right? So we're going from here to here. So from 2 to 4, which is 2 seconds. Now what does that mean? Right? What does that mean there? Like what's the meaning of the period? Right? Good. Well, what's a full rotation in this case? Right? In this case, it's 2 seconds to complete a full jump. Right? Right, it is one full rotation, but we want to go through, okay, what does it mean in terms of real world meaning? So write the equation for axis. What's the axis of that curve? Where's his like middle height along those curves? What's the axis of the curve for that one? Okay, oops, I need to move that over a little bit. So if we take our max, our axis of the curve is max plus min divided by 2, right? So our max is here is 4. Our min is what? 0.5. So 4 plus 0.5 divided by 2. 4.5 divided by 2. So 2.25 is our axis of the curve. Good. Then lastly, what's his amplitude of his jump? So how high is he jumping every time? Right? Is max minus our min. So in this case, it's 4 minus 0.5 divided by 2. 3.5 divided by 2, which equals 1.75. Okay? Alright. So here, let's take a look at this here. Okay? We're going to compare these two charts. Okay. Trying to get it centered so we can. So amusement park, at an amusement park, a math teacher apparently had nothing to do and no children. So he had two students ride two Ferris wheels. Anne rode Ferris wheel A, and Mary rode Ferris wheel B. The teacher made these graphs with the data. Okay. Calculate and compare various aspects of each curve in context. Okay. So what that means is, let's go through all these things and figure out within context what it is. So I'm going to do, let's draw a line through the middle here. I'm going to do Ferris wheel B, okay? Then I want you to do Ferris wheel A, and you're going to tell me the answers as we go through. So let's start with max. Okay, my Ferris wheel A, my Ferris wheel B, its max here is 7 meters. What's your Ferris wheel's max? Anyone tell me in chat? Or live, yell it out. Not 12, 13. Right, a little bit above 12. So what does that tell you in context of what's going on here, right? What does the maxes tell you about the Ferris wheel? Let's say you rode on Ferris wheel A, I rode on Ferris wheel B. What's the max tell you in real world content? What's the max telling you? Picture you on that Ferris wheel with the y-axis being height and the x-axis being time. How high it went. Good. So you guys have the bigger Ferris wheel. Okay? So okay, let's look at minimum value. Okay? My minimum value, I should have wrote minimum in a different color. Oops. Yoink. And my minimum value here is 1. Okay? That equals 1. What's your minimum value? Good. 1. Now what does the minimum value tell you? If you think of a Ferris wheel going around, the minimum value is how close you get to the ground. Lowest height, yeah. Lowest height, or how close you get to the ground, right? Now we both go 1 meter from the ground. Okay. So let's go on to our axis of a curve. Our axis. Okay. Now mine here, I'm going to take take a look at my formula, max plus min. So I'm going to go 7 plus 1 divided by 2, which equals 8 divided by 2. So my axis of a curve is 4 meters. Okay. Can someone tell me your axis of a curve? 7? Do we agree with it? Oh, both you said it? Okay, so I must agree with you. So we had 13 plus 1 divided by 2, 14 equals 7. Good. So that would mean the middle of our Ferris wheel, right, are located at these heights. My middle of my Ferris wheel is at what number? 4? Right? So my middle goes across there, while your middle goes across here. Perfect. And then what about the amplitude? Amplitude. Do I ever have an answer coming in? You guys slow down. I haven't done mine yet. So my amplitude is max minus min. 7 minus 1 divided by 2 equals 6 divided by 2, which equals 3. Okay, so 3 up and 3 down. Now, you guys have told me 6. 13 minus 1 divided by 2 equals 12 divided by 2 equals 6. Okay, here's the what's the context for this? I'm going to give you a hint. What's that 6 represent? What's a horrible 6? Oh, we can play hangman. Set up a little hangman here. Okay. Who wants to guess a letter? What does the 3 and the 6 represent in the Ferris wheel? A? Yep. A right there. M? Nope. E? Nope. I. There is an I. Where are we here? Think about a Ferris wheel. What would the amplitude represent in the Ferris wheel? McCann, I want to say you should be able to get this one. McCann's a very mechanical brain, and that's a compliment, McCann. Fine, who else wants to guess a letter? B? No B. O? No O. L? No L. S? There is an S. Think about what shape a Ferris wheel is. Radius, very good. That represents the radius of the Ferris wheel. Okay? Because if you think about it, there's my wheel, right? How far it goes up and down is equal to the radius. Does that make sense to everybody? Right? Once you see it, it kind of makes sense. All right. Oh, we got to do a history lesson here. Who knows what a water wheel is? Who can picture an old mill by a river? It could be, yeah, it could be. I think in the past they use it like in mills to ground flour. Do you see the wheel right there? That's what a water wheel is. So the idea is, that's not a very good one because the water's not. I got one more in action. But the idea is like the current of the river pushes the wheel, and then it transfers that power inside into where's a good picture? There we go. So there's an example. So the water would be coming this way, and it would push the wheel around. So that's what a water wheel is. Okay? So So Angus is visiting, Angus, I love the word, I love the name Angus, is visiting a historical site that has 2 working water wheels. He knows that there's a large spike at the circumference of each wheel. He studies the motion and constructs these 2 graphs. Okay? So calculate and compare the various aspects of each curve and describe the significance. Okay? So let's kind of do the same. Do you guys want to do the same thing where I do one and you do the other one? Okay. I'll take the right-hand side again, since I don't want to confuse people. That's going to be mine, and left side is going to be yours. Okay? So, did we never do period up here? Oh, we never did period. Both periods are the same-ish. Oh, no. Yeah, let's get rid of it. We'll do period down here. Okay, let's do period right away. Okay, what's the period of mine? So I'm going to select the 2 high spots. Oh, of course, my period's ugly. I'm going to select here and here. I'm going to round so it takes the same one. So I'm going to round and go 1, 2, 3, 4, 5, 6, 7, 8, 9. So my period is 9 seconds. Okay? So I went from one top to another top. Okay? Yours looks like it's in the middle. Is your period also 9? We have 6 and 9 here. Let's take a look here. I'm going to put a mark here, a mark here, and count the spaces. Then go 1, 2, 3, 4, 5, 6 seconds. The 6 seconds is the period. Okay? So what does that tell you in real world terms about the water wheel? Okay? If it's 6 seconds, what's that mean in terms of the water wheel?
6 seconds to go fully around.
Good. Time to do a full rotation of the wheel. Okay? Time takes a spin. Good. 1 full spin of the wheel. Good. Perfect. Okay, let's do max here. My max looks about, my max is 5.5. I go to the top and I go over. What's your max look like? 3.5. Good. So what's that mean in terms of real world? What does 3.5 mean? What's your 3.5 and my 5.5 mean? The max height, not the spike, it's not a spike of the wheel, right? So the highest point, now in this case, oh my god, what did I just write? Now in this case, it's the highest point above the water. So you could picture like this is the water level, right? So in this case here, it is the highest point above the water. Does that make sense, everyone? Now what's our minimum here? You can pick, my minimum is going to be 0.5. And what's your minimum? Same thing? Oh, negative 0.5. Oh, you corrected me. Not 1.5, right? So if we take a look here, there's 1. If we draw a line over, it's going to be at 0.5. So what does that mean in real world terms? In the case of this water wheel, what does that mean?
Underwater.
How far does the water wheel go underwater? Not just lowest point. but the wheel goes 0.5 meters under the water. Okay, very good. Now, what should we do next? The axis of a curve? Let's do our axis of a curve. Now on my side, what color? Let's use green now. It's max plus min. So 5.5 plus negative 0.5 divided by 2. 5 divided by 2 equals minus 2.5. Yours is 1.5? So you had, what? 3.5 plus negative, oops, where'd that come from? Good. What does that mean in real life terms? No, radius is the next one, right? So I would say in real life terms, the middle of the wheel is 2.5 meters above the water. Okay? So in context, remember how I drew that water in there? Oh, I'll erase the, oops. Okay, let's get the draw. Yeah. Explain, oh, we're almost done this, and then you'll have till noon. Yeah. So the middle of the wheel is blank above the water. In my case it's 2.5, in your case it's 1.5. Now, as Lawrence already said, the amplitude is where you're looking at the size of the wheel, or the radius of the wheel. Okay? So my radius, you guys already done it, wait for me. So I have 5.5 minus 0.5 minus negative 0.5 divided by 2. That's going to turn to a plus, so it's going to be 6 divided by 2 equals 3. And yours is 2. 3.5 minus negative 0.5 divided by 2 equals 4 divided by 2, which equals 2. Okay? Yes, you have your quadratic stuff to work on. Okay? So that means the radius of the wheel, right? This means the radius of the wheel. Okay? Good. So we're kind of like we have to kind of understand what it's telling us, right? It's good that we can kind of figure out what all the answers are, but if we can't interpret it, it's kind of useless. Right. So I think there's 2 more examples here. So now we have to sketch our own graph using words. Okay? So I'll do the first one, and then the second time through I'll see if you guys can do the second one. Okay? A boat is floating on the ocean on a wavy day. At the point where the boat is floating on the water 10 meters deep, at the point where the boat is floating on the water 10 meters deep, and the waves are cresting 2 meters, cresting at a height of 2 meters. If the waves are coming every 6 seconds, sketch the situation. Okay. There's a lot to go through there, right? So let's kind of break this down first. So our boat is floating at 10 meters. So that's going to be my starting point. Okay? Our boat is floating at 10 meters. Are you asking for this question, Lawrence? What's the period? We'll get to it as we go. So let's just draw it out first. Okay? So I know our boat is floating at 10 meters. Now if the waves are 2 meters, right, that means it's going to go up 2 meters and the wave's going to go down 2 meters. Okay? So if we put a check here where it says 12, that's as high as it's going to go, and the low part of my wave is going to be at 8. Okay? So that kind of takes away, so this, the first part of the information was this. The waves are cresting at a height of 2 meters. So that was our second part here. If the waves are coming every 6 seconds, okay, so that means it takes from one start of the wave, the end of the wave is going to be 6 seconds. So that's going to be our period here, okay? So I know at 6 seconds our wave is going to be done, right? I'm going to mark halfway through my wave, which is 3. I'm going to put my line down here as kind of a general guide. So I know that halfway between, so we had to do this full rotation in 6 seconds. So halfway, this will all come to you, we'll practice it. So if this is 6 seconds, right, halfway is going to be 3. So I can go like this. Okay. Does that make sense to everyone how I drew that? Okay, I kind of take some like parsing out of the information of, okay, right, this happens. What I do is I take my full period and I cut it in half. That gives me a midpoint. Now, if I was going to be really accurate, I cut these again in half. Oops, that's just 4.5. Right? Because hypothetically, that's going to be at the highest point, and this time period is going to be at the lowest point. Okay. So what's our information here? Let's write down what's my max, what's my min, what's my period, period, what's my amplitude, ooh, I wrote that in the wrong order, which will mess people up. What's my axis, and what's my amplitude. Okay. Well, first things first, let's do period. What's my period of this curve? What's my period of the wave going? 6 seconds. Good, because it takes 6 seconds to go through the full wave. Okay. What's my axis of a curve? We kind of dealt with that very first part. What's the middle part of my curve? No, looking at the y-axis. What's the middle of my curve? 10, very good. What's my max? What's the highest I get? What's my max number? 12. And what's my min number?
8.
And what's my amplitude?
Yeah,
Well, how far from the axis to the top? Axis to the bottom? 2.
Probably 2.
Right? How about this one? And sometimes it's, for some pictures, like that's a hard one to kind of think about because you don't really know a boat. But a car tire has a radius of 45 centimeters and rotates every 15 seconds. Sketch a graph from this information. Okay. So here's my wheel. Okay. Has a radius of 45 centimeters. Good. So sometimes when I do these questions, I think about a starting point. If that makes sense. Like I want to start somewhere. Because a wheel is just a circle. I have no clue where it starts and finishes. Okay? So I'm going to start my wheel. Do you want to start the wheel on the top, the bottom, or the middle? Whoever gets their vote in first wins. Top. Alright. So I'm going to picture like a, let's say you're standing up on this wheel. Okay? So if I were to start here, that would be right here. Now how high up is that? If the radius is 45, how high up am I going to start? If the radius is 45. 90, very good. Right, because 45 here, 45 there on radius. Okay, how long does it take to go through a full rotation? 15 seconds. So I'm going to set out 15 way over here. That's when my dude goes all the way around, and he'll be back up on top. Will take 15 seconds to go all the way around. Okay? Does that part make sense? How I kind of figured that out? Good. Now I'm going to mark halfway. I always like to mark my halves, which is 7.5. So halfway in time, where's my guy going to be? Here. Is he going to be at the sides or the bottom? Halfway through his rotation. If it takes 15 seconds to go all the way around, halfway through, where is he going to be? The bottom. Very good. So he's going to hit the ground at that point. And if you look, we just made our curve, right? And if it kept going on here, it would go again like this. But that was 30 seconds here. Does everyone kind of see my reasoning? How like I kind of drew a picture and kind of reasoned through how to draw my picture? Right? Sometimes a little picture and a little stick guy kind of works. I sometimes ask on a test like a nail's in there. You ask how like the nail's path around here. So let's go through here and figure out our max, min, I put a period up here, period, max, min, axis, and our amplitude. I'll let you write in chat whichever one you want to solve for. Max is 90, very good. Because that's the highest point we're at. Period is 15, because that's how long it takes to do a full rotation. Good. Rotates every 15 seconds. My min. Not 7.5. Think about a tire rolling on the ground. 0 because it's on the ground, right? This is 0 here when we squish our dude who's riding around the circle. Who can tell me, what's my amplitude? Now we could use this. We could use our formula to find the amplitude, right? not 7. Sorry, let's go amplitude. Let's go amplitude, right? Amplitude is max minus min. So 90 minus 0 divided by 2, which is going to equal 45. So that's my amplitude there. And it tells us here the radius, right, is 45 of our tire. Oh, you're looking at 15. I understand. Yep, that makes sense. And our axis is max plus min, and it just happens in this case they're both the same. Those two. Because it makes 100% total sense that the middle of the tire rotates around the middle. Okay? So, first things first, it's kind of building on what we did the last 2 days, last 2 lessons. Hopefully it kind of makes sense, but it's a little bit different. Do not leave the call for me right now. I have to put something together. So your homework, let's double check my homework to make sure I taught you everything I need to. So it has some questions about, so the first couple questions are kind of reasoning about it, right? How long does it take for the jumping to become periodic? What's the period? What's the amplitude, right? What's the amplitude? What's the amplitude mean, correct? So some of those are just knowledge-based, right? Then we have one where we want you to draw out a diagram. Okay? Thank you, Trin. I want you to try to draw out that diagram of it's actually a swinging ship this time. Do you guys know what I mean by a swinging ship? Have you guys seen that? So this is a swinging ship ride as it goes back and forth. Okay? You can picture that. So there's one at Canada's Wonderland for sure. So the fair ride swing ship, you stand at one end, right? The ship swings right towards you. The ship swings within 5 meters from you, and then swings 15 meters away from you. Okay, so the closest gets 5 meters, furthest away is 15 meters, takes 20 seconds. Okay? Make sure you draw 3 complete swings as you do that work.